Hi, my name is Joel Matthew. You are 15CS177. I'm a student of Carnegie University, and today I am going to be explaining one of my lab programs from Data Structure Lab, which is the array implementation of Stack. So Stack is actually a linear data structure, and data structure is any structure which is used to store a collection of data. This data can be similar or dissimilar. In Stack, we actually store only similar data types, and in this case, we are going to assume that the elements of the stack are of integer data type. Stack is also a LIFO data structure, which means that which means last in first out, which means that the last element which is inserted into the stack is the first one to be deleted from the stack. We are also going to be performing the operations push, pop, and display, and we are also going to be printing the appropriate messages for stack overflow and stack underflow conditions. So initially, I have written the header file iostream and using namespace std. I've also declared an array, which is a global variable in this case, stk, and two more variables, s and top, and I've also initialized top as -1. These are the prototypes for the functions which I'll be using later on in the program. So in the main function, I have again declared three variables: choice, lim, and ch. So the user is first asked to enter the size of the stack, and I've used a while loop so that it allows the user to implement the operations as many times as the user wishes. So first the user is asked for the choice of operation push, pop, or display, and the choice is executed using switch case. So in case 1 we have the push operation. So the user is asked to insert an element and the push function is executed. So here's the push function, and we have to send the element entered by the user is sent to the push function. And first we check for stack overflow condition. So top is greater than equal to size of the stack is checked. If it's true, then the stack is full and it's returned back to the control is returned back to the program. And if not, then the element is inserted into the stack, and the inserted element is shown here, displayed here. So we come back to case 2, in which the pop operation is executed. So we go to the pop function. So first underflow condition is checked. So if top value is less than 0, then stack is empty and -1 is returned back to the program. And if not, then the deleted element is displayed here, and we come back to the switch case, and case 3 is display function. So we display the stack and the elements in it. So here's the display function. First, using if else, first we check whether if the stack is empty. So if top is less than 0, then the stack is empty, and this is displayed. And if else condition is that the stack elements are actually displayed from last to first. So, and if any of the choices given by the user does not match, then the default condition is executed, and the user is also asked if he wants to continue. If yes, the loop is again executed, and if not, then we exit from the while loop. And let's see how the program runs. So the user is asked the size of the stack. So let's enter 3, and we are asked for the operation to be executed. First, let's insert some values. Yes. And again, let's insert another value, 3, and we want to continue. Yes. Let's display the values, and as you can see, the last element which we entered 3 is shown first, then the next first element. And if we want to continue, yes, let's see the pop operation, and 3 is actually deleted, which was the last element which that we entered. So let's once again display the elements, and only the first element 2 is left in the stack. So do we want to continue? No. And as you can see, the stack operations are implemented. Thank you for listening to me.